I'm introducing the core topic, Lasso regression, and what it means when we get zero coefficients. We'll explore why these zeros appear and what they tell us about our data. It's like detective work. Imagine you're using Lasso to predict house prices. You get some coefficients equal to 0. This is our mystery we need to solve. We want to understand what these zeros actually mean. This sets the stage. I'm using a popular machine learning library, Sklearn, and its Lasso regression tool to make house price predictions based on various features. The interesting part is that I get some zero coefficients in my results. What do these zeros signify? Here's a key clue. Lasso's ability to produce zero coefficients hinges on its alpha parameter. This parameter controls the strength of the regularization, the penalty that pushes coefficients towards 0. A non-zero alpha is essential for Lasso to perform feature selection effectively. Let's break down Lasso. It's a regression technique that adds a penalty to the usual error calculation. This penalty is proportional to the sum of the absolute values of the coefficients, called L1 regularization. This forces some coefficients to become exactly 0, simplifying the model and performing feature selection. Think of it like this: the standard error calculation tries to fit the model perfectly to the data. Lasso adds a penalty term which is calculated as alpha multiplied by the sum of the absolute values of all the coefficients. This addition makes it prefer simpler models with fewer variables. A larger alpha means a stronger penalty, leading to more zeros. That's the magic of Lasso. I see Lasso regression as a powerful tool for choosing the most important features in your data. It's like having a smart assistant that sifts through all your variables and picks out only the ones that truly matter for your predictions. This is achieved by shrinking the coefficients of less important features to 0. The question tests your understanding of how Lasso regression works for feature selection, specifically focusing on the interpretation of zero coefficients. Think of it like this: you're trying to predict house prices, and Lasso helps you decide which factors, size, location, etc., are really driving the price. The Lasso model, at its core, uses a technique called L1 regularization. Imagine it as adding a penalty for having too many features involved in the prediction. This penalty encourages the model to favor simpler explanations by setting the coefficients of unimportant features to 0. This is absolutely correct. Because Lasso aims to minimize the error in its predictions while keeping the model simple, it will discard features that don't significantly improve the accuracy, even if they're included. It's like deciding if a new ingredient is worth adding to your recipe. If it doesn't improve the taste significantly, you'll leave it out. The penalty term, alpha, controls how strongly the model prioritizes simplicity. This is also true. The alpha parameter in Lasso controls the strength of this penalty. If alpha is 0, there's no penalty, and Lasso is just regular linear regression. But with a non-zero alpha, Lasso starts shrinking coefficients, and some features might even have their coefficients become exactly 0. I would say this statement isn't necessarily true. While highly correlated features can influence the selection, Lasso doesn't directly deal with correlation. Instead, it focuses on minimizing the loss function, including the penalty term, alpha. We're diving into Lasso regression, a powerful technique in machine learning that helps us select the most important features from our data. Think of it as a smart filter for your data, allowing you to focus on what really matters. Lasso achieves this through a process called regularization, which I will explain shortly. It helps us build simpler, more robust models by cleverly discarding less influential features. In Lasso regression, we get a set of numbers called coefficients that represent the importance of different features in predicting our target. For example, house price. Some of these coefficients might turn out to be exactly 0. This quiz asks what these zeros tell us about the corresponding features. This is correct. This is a key idea. Lasso tries to find the best balance between accurately predicting the target variable and keeping the model simple. The penalty term is a mathematical tool that punishes us for having too many features. If a feature doesn't contribute much to prediction but adds to this penalty, Lasso will set its coefficient to 0, effectively removing it from the model. Think of it as a cost-benefit analysis for each feature. Absolutely. This is another important point. The alpha is a tuning parameter that controls the strength of the penalty. A higher alpha means a stronger penalty, pushing more coefficients to zero. If alpha were zero, Lasso would behave exactly like ordinary least squares, with no feature selection happening. So, the zero coefficients show that we used a non-zero alpha. This is incorrect. While the zero coefficient means the feature doesn't affect the prediction in this specific Lasso model that doesn't mean it's completely useless. Other models or different datasets might find it useful. It's just that for this particular scenario and the regularization penalty selected, Lasso deemed it unimportant. This could be the case but isn't guaranteed. High correlation can lead to one feature being favored while others are dropped, but this is not always the case. It's not a direct consequence. Lasso doesn't inherently deal with correlation. It balances prediction accuracy with the model's simplicity through a penalty term. Lasso regression is a method we use to pick the most important features when predicting something. Think of it like choosing the most important ingredients for a cake. You wouldn't use every ingredient in your pantry, right? Lasso helps us pick only the most impactful features, for our prediction. It does this using a special penalty that makes less important features' values become zero. That's feature selection. We're using Lasso to predict house prices. We have lots of information about houses, size, location, etc. And Lasso will help us decide which pieces of information are most important for accurate price prediction. This is a key concept. The alpha is like a dial that controls how strongly Lasso pushes those less important feature values towards zero. A higher alpha means a stronger push, leading to more features being deemed unimportant. If alpha is zero, we're basically just doing regular regression, without any feature selection. Lasso tries to find the best balance between making accurate predictions and keeping the model simple. Imagine you're building a model. You want the model to be accurate, but you also want to avoid overly complex models that might overfit the data. This is what Lasso does. If the extra gain in accuracy from including a feature is less than the penalty added by including it, the coefficient, the importance, of that feature is zeroed out. It's all about finding that sweet spot. Just because a feature's coefficient is zero in this Lasso model doesn't mean it's totally useless. It might be important in a different model or with different data. It's true that highly correlated features can influence Lasso's decisions, but it's not guaranteed that one of them will always have a zero coefficient. Lasso considers the predictive power of each feature, even considering other similar features, as well as the penalty incurred to maintain it in the model. We're diving into Lasso regression, a powerful technique that helps us build predictive models while also selecting the most important features. A key aspect of Lasso is its ability to shrink some coefficients, the numbers that represent the importance of each feature, down to exactly zero. This is fantastic because it helps us simplify our models and prevent overfitting. That's when a model is too closely tied to our training data and doesn't generalize well to new, unseen data. So, Lasso effectively performs feature selection automatically by deciding which features are really crucial. Let's imagine you're using Lasso to predict house prices. Some features end up with a coefficient of zero. Now, the question is, what does this mean for those features and what does it tell us about the way Lasso operates? Absolutely. Lasso needs a non-zero, alpha, value to do its magic. Think of alpha as a dial controlling how much Lasso cares about simplicity versus accuracy. A higher alpha means Lasso prioritizes simplicity, leading to more zero coefficients. If alpha is zero, Lasso is just regular least squares regression and it won't shrink any coefficients to zero. Exactly. Lasso aims to find the best balance between predicting well and keeping the model simple. It considers both the prediction error, loss function, and the size of the coefficients, penalty term. If a feature doesn't improve the predictions enough to justify its inclusion, Lasso will zero out its coefficient. It's like Lasso is saying, this feature isn't worth the extra complexity. This is a bit tricky. While high correlation can affect Lasso's choices, it doesn't guarantee a zero coefficient. Lasso might choose one of the correlated features and ignore others, even if they have similar predictive power. I wouldn't say that. A zero coefficient only means that this specific Lasso model didn't find the feature useful. However, the feature might be important in other models, or even in this one if you change the alpha value, or if more data is available. I see this as the core topic. Lasso regression is a technique we use to pick the most important features in a dataset. We use this method to predict a dependent variable, like house prices, based on independent variables, features like size and location. Lasso helps us to get rid of features that aren't really helping with the prediction. This is the heart of the problem. In Lasso regression, we get coefficients that tell us how much each feature affects our prediction. If a coefficient is 0, it means that Lasso has decided this particular feature is not important at all for our prediction and has effectively removed it from the model. This is true. Alpha is a tuning parameter in Lasso that controls the strength of the penalty imposed on the size of the coefficients. If alpha is greater than 0, it shrinks some coefficients toward 0, resulting in feature selection. Think of it as a dial. The higher you set alpha, the more coefficients go to 0, the more features you drop from your model. A 0 alpha means there's no penalty. It basically becomes a regular linear regression which does not perform feature selection, hence it won't have 0 coefficients. This is also correct. Lasso aims to balance prediction accuracy with keeping the model simple. The model tries to predict house prices accurately while simultaneously penalizing the use of many features. A 0 coefficient indicates that the feature's contribution to prediction accuracy is outweighed by the penalty we've applied to it. The model essentially says, this feature isn't worth the added complexity. This statement is not always true. While high correlation can cause Lasso to set some coefficients to 0, it is not a guarantee. Lasso doesn't explicitly handle multicollinearity, correlation between independent variables, in the same way that other methods do. It might favor one feature over another highly correlated feature based on how useful it is for prediction, even if both correlate well to the dependent variable. This is incorrect. A 0 coefficient only means the model didn't find that feature useful in this context. The feature itself might indeed affect house prices. It's just that Lasso didn't pick it up as significant in this specific model. This is the specific statistical model used here to predict house prices. It's a linear model which applies L1 regularization to shrink less important coefficient to exactly 0. This refers to Lasso's ability to automatically select relevant features. By setting some coefficients to 0, it effectively removes those features from the model, leaving only the most important ones.